There's a planet, 640 light years from here, where it rains molten iron, not rust, not dust, pure liquid metal, falling at 7,000 kilometers per hour. This isn't science fiction. This is WASP-76b, and that's just the beginning. Tonight, you're going to see 20 worlds that will rewrite everything you thought you knew about planets. Worlds so extreme, so hostile, so impossible, that our laws of physics barely explain them. Some burn hotter than stars, some freeze while they burn, some wander space with no sun at all. And one of them is growing right now, at 6 billion tons per second. You ready? Let's go. First stop, WASP-76b, a gas giant nearly twice Jupiter's size, orbiting so close to its star that 1 year lasts just 1.8 Earth days. The day side reaches a scorching 2,400 degrees Celsius, hot enough to vaporize iron. This planet is tidally locked, meaning one side always faces the star, while the other side is cast in eternal night. The day side is a furnace. The night side is still a blistering 1,500 degrees Celsius, which is considered cool here. So here's what happens on the day side. Iron doesn't just melt, it evaporates. It becomes a gas, then supersonic winds drag that iron vapor over to the night side. There it cools, condenses, and falls as liquid iron rain. Imagine that, droplets of molten metal falling through toxic clouds forever. In 2024, scientists using the Cheops telescope discovered rainbow-like optical effects in its atmosphere. But this rainbow isn't made of water. It's made of vaporized metal. A perfect fusion of beauty and violence. Ask yourself, could you survive even 10 seconds here? Now let's move from a world of fire to a world of paradox. Some planets freeze, some burn. Gliese 436b does both. It's 40 light years away and about the size of Neptune. Its surface temperature is a staggering 700 degrees Celsius. And yet, it's made of ice. How is this possible? The planet's immense gravity crushes water molecules so tightly that they cannot melt, even when they're burning hot. Scientists call it hot ice that would glow white beneath your feet. The pressure is so extreme that water molecules are forced into exotic crystalline structures that don't exist on Earth, like Ice 7 and Ice 10. These are forms of ice that remain solid at temperatures that would boil our oceans. It's an entire world frozen solid simply because physics forbids it to melt. Fire and ice, the same thing, on the same world. Gliese 436b orbits a red dwarf star every 2.6 Earth days. The star's radiation bombards the surface constantly, yet the ice endures. This planet is a paradox made real. Next, meet 55 Conchrae. It's 40 light years away, twice the size of Earth, and 8 times the mass. A year here lasts only 18 hours. The surface temperature is a constant 2,400 degrees Celsius. The ground doesn't cool, it flows. Rivers of lava cross entire continents. Molten stone rains from orange skies. But here's the incredible part. This world is so rich in carbon that under its crushing pressure, that carbon transforms into diamond. Not just gemstones, continents of it, mountains of diamond kilometers thick. Scientists estimate that up to 1/3 of the planet's entire mass could be pure diamond. Imagine that, a hemisphere made of the hardest substance in the universe, a treasure chest locked in eternal fire. The atmosphere is thick with carbon vapor and silicon. Clouds of vaporized rock drift across skies glowing with reflected lava light. This is a super Earth in the worst possible sense, massive, hostile, and utterly inhospitable. And yet, it's one of the most valuable objects in the known universe. Those 3 worlds, believe it or not, they're the normal ones. Now, let's journey to a place of absolute darkness. Some planets shine, but TRES to be swallows light. Located 750 light years away, it reflects less than 1% of the light that hits it. It's darker than coal, darker than the blackest paint humans have ever created. If you were to see it from orbit, you would see nothing. Just a void, a hole in space where a planet should be. The only thing you detect is a faint, deep red glow, like eyes staring back from the dark. This planet doesn't just look dark, it is darkness. Scientists believe its extreme temperature of over 1200 degrees Celsius breaks down atmospheric molecules, creating special light-absorbing compounds. Things like titanium oxide and vaporized sodium create a chemical soup that devours photons. TRES orbits its star every 2.5 days, and despite being so close to a bright sun, it remains almost invisible. Stare at it for too long, and you start to feel like it's staring back. Now, let's flip everything you know on its head and visit KELT 9b, a planet hotter than most stars. Its temperature reaches an unbelievable 4,300 degrees Celsius. It's so hot that molecules are literally torn apart. Hydrogen and oxygen cannot stay together as water. Chemistry itself stops working. There are no clouds here, no weather. Just a boiling plasma in a white-hot atmosphere. This planet is so hot that it glows blue-white, just like a star. Iron, magnesium, and titanium don't exist as solids or liquids. They evaporate into gas, filling the air with heavy metals. But this heat comes at a cost. The planet is evaporating. Its mass is bleeding away into space at a staggering rate of 10,000 tons per second. In just a few million years, KELT 9b will simply be gone. Scientists discovered this world using the KELT telescope network, and it remains one of the hottest exoplanets ever found, hotter than 70% of all known stars. If you could somehow stand on KELT 9b, the sky would be blinding white, the ground beneath you would be glowing plasma, and you would disintegrate in less than a millisecond. From a distance, our next stop, HD 189733b, looks peaceful. It's a beautiful blue marble drifting in space, much like our own Earth. But get closer, and the illusion shatters. The temperature here is 1,000 degrees Celsius. The winds scream at 7,000 kilometers per hour. And carried in those winds, silicate particles, microscopic shards of glass. It rains glass, sideways. The planet orbits its star every 2.2 days, and is tidally locked, creating a massive temperature difference between its day and night sides. This difference generates winds faster than the speed of sound. These winds carry silicate particles, tiny grains of glass, which are formed when vaporized minerals condense in the cooler nightside atmosphere. Then, they are swept back to the dayside at hypersonic speeds. It's a hurricane made of blades, beautiful from afar, but up close, a terrifying killing machine. When the Hubble Space Telescope pulled the planet's deep blue color in 2013, scientists briefly hoped for water vapor. Instead, they found death. Now, witness a planet in its death throes. WASP-12b is dying, and we are watching it happen. The gravity of its parent star is tearing the planet apart, stretching it, deforming it. Its atmosphere is being pulled away, streaming into the star like a river of fire, losing millions of tons of mass every single second. This planet isn't even spherical anymore, it's egg-shaped. The gravitational forces have stretched it so severely. Material from the planet flows toward the star in a glowing accretion stream. Scientists estimate that WASP-12b loses 6 billion tons of mass every single year. At this rate, in just 10 million years, there will be nothing left of WASP-12b. It will be a planet executed by its own sun. This is the brutal reality for planets that orbit too close. The star wins, always, but some planets refuse to die, even after their star has. Meet PSAB 125712a. This world orbits a pulsar, the corpse of a star, a spinning neutron core that fires beams of deadly radiation every few milliseconds. Imagine living under a cosmic lighthouse that strobes with enough energy to sterilize a solar system. It's a testament to the resilience of planetary formation. Even after a supernova, worlds can be born from the ashes. These are just a few of the impossible worlds out there. Each one challenges our understanding of the universe and reminds us how truly strange the cosmos can be. When the first pulsar was discovered back in 1990, astronomers were shocked. It was a dead star, spinning hundreds of times a second. Then, they found planets orbiting it, impossible planets. The original star had exploded in a supernova. Anything in its orbit should have been completely vaporized. Yet 3 planets survived, or maybe they formed asterisk after asterisk the explosion. The innermost of these is PSAB 1-57 plus 12a. Anything hit by the pulsar's lethal radiation beams is sterilized instantly. This world has no atmosphere, no chance for life. But it exists. It's a survivor of a cosmic apocalypse. The universe tried to destroy it, but it refused. These are called pulsar planets, and they're among the strangest objects we've ever found. They orbit a corpse, a dead star that sweeps the system with death rays like a cosmic lighthouse. And yet, the planets endure. Sometimes, death can be beautiful. The planet J1407b proves it. It's a gas giant with a ring system 200 times wider than Saturn's. If it replaced Saturn in our sky, its rings would stretch from horizon to horizon, casting shadows across entire continents. The ring system is so massive it spans over 120 million kilometers. For comparison, the distance from Earth to the Sun is 150 million kilometers. But inside those magnificent rings, pure chaos. Moons are forming and then shattering. It's a graveyard of worlds locked in eternal collision. Scientists believe we're witnessing the birth of a moon system, just like Saturn's, but on a scale never seen before. When J1407b passed in front of its star in 2012, the star's light dimmed in a complex pattern that lasted 4 weeks. Analyzing that pattern is how we discovered the ring structure. This planet is building moons right now, and we get to watch. Most planets we know orbit stars, but some drift in total darkness, alone, no sun, no day, no light, forever. These are rogue planets, and here in our galaxy, they could outnumber stars 20-1. That means trillions of worlds wandering the void. They were ejected from their original star systems, kicked out by the gravitational pull of other planets or stars. Now they drift through interstellar space, orphaned and alone. One of them is Char 1109-13773444, about 620 light-years away. It's 5 to 10 times more massive than Jupiter, and it's still growing. It's devouring gas and dust at a rate of 6 billion tons per second. This planet is evolving right now. It's not orbiting a star. It's drifting through a molecular cloud, pulling in material as it goes. It's like a planet that thinks it's a star. Astronomers found it back in 2004 using infrared telescopes. It glows faintly from its own internal heat, the leftover warmth from its formation. Other rogue planets roam in pairs, 2 orphans orbiting each other in an eternal night. Binary rogue planets, dancing through the darkness. Some might even hide vast oceans beneath thick ice shells, kept warm and protected by internal heat and tidal forces. They could even harbor life that has never seen a star. They are everywhere, invisible, waiting. But you don't need to travel light years to find nightmares. Just look next door, Venus, Earth's supposed twin. Same size, same mass. It should have been a paradise. Instead, it's hell. The surface temperature is 465 degrees Celsius. The atmospheric pressure is like being a kilometer underwater, but in toxic gas. Acid clouds rain sulfuric acid that evaporates before it even hits the ground. Winds wrap the entire planet in a super hurricane, circling the equator in just 4 Earth days. 1 day on Venus is longer than 1 year, and the sun rises in the west. Probes we send there die within hours. The Soviet Venera landers lasted 90 minutes at most. Their cameras captured horrifying images of a hellish landscape, scorched rocks, choking dust, and crushing, yellow skies. Venus wasn't always like this. Billions of years ago, it might have had oceans, it might have had life. A climate much like early Earth. Then, something went catastrophically wrong. The greenhouse effect spiraled out of control. The water evaporated, carbon dioxide flooded the atmosphere. Temperatures soared until the oceans boiled away into space. Venus is a warning of what happens when a planet dies screaming. And it's a chilling reminder that Earth could follow the same path. Then there's Mars. We see a future there, but Mars already had its chance. 3.5 billion years ago, it had water, an atmosphere, heat, and maybe even life. Rivers carved out valleys, lakes filled craters. The entire northern hemisphere has been covered by a vast ocean. Then, its magnetic shield died. Without that protection, the solar wind stripped away the atmosphere, molecule by molecule. The water froze, then sublimated into space. The rivers dried up, the lakes vanished. Mars didn't die naturally. It was murdered by the sun, by physics, by time. Today, Mars is a frozen desert. Dust storms rage 4 months on end. Temperatures at night drop to -130 degrees Celsius. But beneath the surface, things might be different. Liquid water might exist in underground reservoirs. Microbial life could still be clinging to existence in hidden, protected pockets. Mars is a cosmic crime scene, and we are the detectives trying to piece together what happened. Let's travel farther out, to Europa, a moon of Jupiter. It's covered in ice, but beneath that shell is a global ocean with more water than all of Earth's oceans combined. It's warm, dark, and possibly alive. Jupiter's immense gravity constantly squeezes Europa, generating tidal heat. That heat keeps the subsurface ocean liquid, despite surface temperatures far below freezing. The ice shell is 10 to 15 kilometers thick, crisscrossed with cracks and ridges. Geysers erupt from these fissures, shooting plumes of water vapor hundreds of kilometers into space. Life here would never see sunlight, but it could still exist right now, feeding on chemical energy from hydrothermal vents on the ocean floor, just like life in Earth's deep sea. NASA's Europa Clipper mission is launching soon to study this moon up close. If life exists beyond Earth, Europa is one of the very best places to look. Now for Titan, Saturn's giant moon. It has a thick atmosphere, orange skies, and lakes and rivers of liquid methane. Rain falls from the sky and fills alien seas. Titan is the only moon in our solar system with a dense atmosphere even thicker than Earth's. Nitrogen and methane create a hazy, orange veil that shrouds the surface. The temperature is a frigid -180 degrees Celsius. Water ice is as hard as rock, but methane and ethane remain liquid. Lakes dot the polar regions, rivers carve channels through icy terrain. Dunes made of organic material stretch across vast equatorial deserts. Titan has 2 oceans, one of liquid methane on the surface and another of liquid water deep below. It's an alien Earth, frozen yet strangely alive. The Cassini mission discovered Titan's lakes in 2004, and the Huygens probe landed on its surface in 2005, revealing a world unlike any other. If life exists on Titan, it would be radically different from anything we know, based on liquid methane instead of water. Some worlds are even stranger. Take Coro 7b, a planet where rock evaporates, turns into clouds, and then falls as a rain of stones. This planet orbits so close to its star that the surface temperature reaches 2000 degrees Celsius. Rocks vaporize, then condense in the cooler upper atmosphere and rain back down as pebbles. Imagine standing beneath a sky raining molten rock. Then there's Kepler-1 6b, 2 suns in the sky, double shadows. This planet orbits a binary star system, 2 stars locked in orbit around each other. If you stood on Kepler-1 6b, you'd see 2 suns rise and set, casting twin shadows across the landscape. It's a real-life tattooing, except it's a frozen gas giant where temperatures drop to -100 degrees Celsius. And one of the weirdest is WASP 193b. It's so light, it has the density of cotton candy. It's a balloon pretending to be a planet. This world is 50% larger than Jupiter, but weighs almost nothing. Its average density is lower than any known planetary object. Scientists have no idea how it formed. It shouldn't exist, but it does. So what does all of this mean? These planets aren't just cosmic curiosities. They are mirrors. Venus shows us what happens when heat wins. Mars shows us what happens when protection fails. Rogue planets show us that worlds don't need stars, and that life might survive anywhere. Since 1992, we've found over 6,000 exoplanets. Billions more remain undiscovered, more planets than there are stars. Think about that. Every single star you see in the night sky probably has planets. And most of those planets are nothing like Earth. But if all these nightmares exist, what about worlds like Earth? Are we the rare ones, the lucky ones? There's Proxima Centauri d, our closest neighbor, orbiting in the habitable zone of its star. It could be like us. It's only 4.2 light-years away, a rocky planet orbiting Proxima Centauri, the nearest star. But that star is a volatile red dwarf, prone to violent flares that could strip away any atmosphere. Still, it's close, and we're watching it. Then there's Kepler 452b, a super-Earth with hints of water vapor in its atmosphere. Maybe it has oceans, maybe clouds, maybe even life. The universe is filled with both horrors and wonders. For every Venus, there could be an Earth. The search continues. Have you ever heard of Kepler 452b? Some people call it Earth 2.0. It orbits a star a lot like our own Sun, right in the sweet spot where liquid water could exist. We don't know for sure if it's truly habitable, but it's one of the most promising candidates we've ever found for a second Earth. Then there's the TRAPPIST 1 system, an absolute cosmic marvel, just 40 light-years away. Imagine this, 7 rocky, Earth-sized planets all orbiting a cool red dwarf star. Not 1, not 2, but 3 of these worlds are in the habitable zone. That means they could have oceans, they could have lakes, they could have life. One of them, TRAPPIST 1e, is especially tantalizing. It's almost a twin to Earth in size and mass, and it gets a similar amount of light and heat from its star. Right now, as we speak, the James Webb Space Telescope is staring deep into the atmospheres of these planets. It's searching for the chemical fingerprints of life: oxygen, methane, water vapor. Think about that. Within the next decade, we might get an answer to the biggest question of all: are we alone? This journey through the cosmos has shown us incredible things. We've seen fire and ice, darkness and destruction. We've found moons hiding vast oceans and rogue planets wandering alone in the dark. But through it all, one truth stands out above everything else. We are fragile. Earth is a miracle. A thin shell of air, a narrow band of perfect temperature, a magnetic shield protecting us from cosmic chaos. We exist in a delicate, perfect balance, not too hot, not too cold, just right. We are a rare pocket of calm on a violent universe. Life found a way to exist here against impossible odds. And maybe that's the real cosmic horror, the realization that we shouldn't exist at all, but we do. So the next time you look up at the night sky, remember this: those lights aren't just distant stars. They are signals from other worlds, places you'll likely never see. Some are fiery nightmares. Some might be untouched paradises, and some might be watching us right back. This is Cosmic Nightmares. Stay curious, stay alive. The universe is still out there. Thanks for watching. And don't forget to subscribe for more journeys into the unknown.